Okay, so today we're looking at chapter 4, lesson 6, and we're going to start to investigate how do we multiply a decimal times another decimal. Um, so we've done a lot of work with how we multiply decimals and whole numbers, but what we're going to move on to now is decimals by decimals. One thing that we need to remember from our study of decimals times whole numbers, right, and let's get out a pen here, is when we were looking at that, we noticed that if we multiply like 3/10 times 4, hopefully, we started to recognize that we don't always get answers that are bigger than both of our factors. So in this case, right, we would ignore our decimal for a minute. We'd say, well, 3 times 4 is 12. And then we'd go back and be like, oh, we moved a decimal of one decimal place. We get 1 and 2/10. And when we compare 1 and 2/10 to 4, 4 is greater than 1 and 2/10. And the reason we end up with this is because we multiplied by 3/10. And when we multiplied by 3/10, we didn't get all of each of these fours, right? So if we think about this idea of if we had right, if we had like 4 pies at home and we ate 3/10 of each pie, right, we wouldn't eat all of the pies because we would only eat 3/10 of each one. Um, so instead of getting a number that is 4 or greater, we get a number that is actually less than 4. When we multiply by numbers that are less than 1, we get answers that are smaller. And so we're going to have to keep that idea in mind as we work through our problems today, because we're going to be multiplying like 3/10 times 4/10, right? And when we do this, we're going to end up with numbers that are even smaller than 1 and 2/10. So let's take a look at a couple. So here's our first one. And it says that the distance from Charlene's house to her school is 8/10 of a mile. Charlene rides her bike 7/10 of the distance and walks the rest of the way. How far does Charlene ride her bike to school? So this is a multiplication problem. And the reason why it's a multiplication problem is because it tells me that Charlene rides her bike 7/10 of the distance. So it's not 7/10 of a mile, it's 7/10 of the distance to school, right? So if this is the distance to school, right, Charlene rides part of it. She rides to, I don't know, 7/10 of this line would be about like right there, right? So this part is how far she rides her bike, and this part is how far she walks. Um, so to find this distance, we need to multiply. We can draw a model to help us to understand this. So first thing we're going to do is we're going to take a look at our picture right here. And as we look at this, hopefully we start to see, kind of like think about it, and we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 rows. And if we counted, 12 columns. And if we counted down, we would count 12 rows as well. So we want to chop this thing up a little bit. We want to cut it off so that it ends up being a 10 by 10. Because if it's a 10 by 10, then each of these little squares inside of here has a value of 100. So that's going to help us as we work to solve our problem. So first step, we want to make sure that we're working with a 10 by 10. Now, the second step, what we want to do next, oops, I don't want to do that, I want this. What we want to do next is I'm going to use a highlighter because it just is a little bit easier. And I want to shade in 8/10 of this picture. So I'm going to shade in 8 longs, right? So 1, 2, 3, 4, 5, 6, 7, 8 longs. So I've shaded in 8 longs, and that represents my 8/10 of a mile. So why don't we write that up here at the top, right? So across the top here, oh my goodness, it didn't change, did it? We have 8/10 of a mile. Now, what I'm going to do is I'm going to change the color of my highlighter because I think it's going to make it easier. And I'm going to model 7/10, going across my picture this way. Well, it doesn't like to draw like crooked lines with the highlighter, does it? Because I want to show that I have 7/10 of this 8/10 of a mile. So I'm going to color 7/10 going this way. So 1, 2, 3, 4, 5, 6, and 7. Right? So I have created this model that has 8/10 going up and down and 7/10 going side to side. When I look at this, if I focus on the part of my model where both of these overlap, this is the part that gives me my answer. So I need to just like count these up, right? But that seems like it might take a really long time. So how about we do this? How about we just like look across and we say, well, there's 1, 2, 3, 4, 5, 6, 7, 8, right? So each of these going across should have 8 in it. Let's count right here. So 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. So if all of these have 8 units going across, how many do we have going down? Well, here we have 1, 2, 3, 4, 5, 6, 7. Right? So what we've basically created in here is this little array that is a 7 by 8 array. And if I were to multiply 7 times 8, I would get 56. I don't know if you can see that very well, right? So let's write it out here. So we would get 56 units inside of here. Well, remember just a minute ago, we talked about the fact that each one of these units has a value of 1/100th. So if we have 56 of them, then we could say that we have 56 hundredths, right? So we could write that as 56 hundredths. So 7/10 times 8/10 gave us 56 hundredths. Well, let's take a look at that idea and see how that number compares to each of our original factors, right? So 56 hundredths and 56 hundredths. Well, 7/10 is greater than 56 hundredths, and 8/10 is also greater than 56 hundredths, right? So this is one of those situations where our product is smaller than both of our factors. And the reason why is because remember we drew, right, those 8/10 going down. And then when we came across, right, we didn't shade in all of that. All we cared about was the part that overlapped. All we cared about was taking 7/10 of that original 8/10. So we only got part of a mile. And so we get a number that's a little bit smaller. Let's try another one. Okay, so here we have our model. We have 8/10 times 9/10. So I'm going to label it. So across the top, I'm going to have 9/10. I'm going to write it right here because I don't have quite enough room. And going this way, I'm going to have 8/10. Now the key is when we shade these in, we have to make sure that we're going perpendicular. Because if we shade it going all up and down, and then we come back and we shade it all going up and down, it's not going to work out. We're not going to get a clear answer, right? So we want to make sure that we are working perpendicular. So let's grab our highlighter and see if we choose 2 different colors, if it works a little bit better this time. So I'm going to start off by doing 9/10, which really means I'm going to shade all but one of these. I guess I should have double checked, right? So we have, that is number 5, right? And then here's number 6, 7, 8, and 9. Yeah, so this is already a 10 by 10. Okay, let's change up my color. And now going across this way, I'm going to do my 8 tenths. So 1, 2, 3, 4, 5, 6, 7, and 8. Now remember, the key is the only part I care about is where they both overlap, right? So they overlap to here and they overlap to here, right? So this is the part of my model that I care about the most. Now, if I pay attention, right, going across the top, right, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 units in each row. And then going down, I have 1, 2, 3, 4, 5, 6, 7, 8, right? So if I wanted to, I could count them all, but instead I'm going to multiply because I know that I've ended up with a 9 by 8 array. Well, 9 times 8 equals 72 units. Again, each of these individual units is 1/100th of the whole. So we have here 72 hundredths. All right. What if we multiply by a number that's greater than 1 with a decimal in it? So this gets a little bit trickier. We can still use the same model, but it's a little bit trickier. What we're going to do for this one is we're going to need two unit models, right? They are both still 10 by 10. So they're both each made up of 100 individual squares. When we do this kind, we want to make sure that we put the number that is greater than 1 going across the top of both of these, right? Because what this allows me to do is for my 1, I can shade in this entire model, right? So I could take my highlighter and I could shade in this entire model, right? Because that is one whole that is shaded in here. That number equals 1. Now, for my second one, though, I'm not going to shade in the whole thing. Here, this is where I'm going to shade in my 4 tenths, right? So I'm going to shade in 4 tenths here. Now, that is my 1 4 tenths going across the top. Now, going this way, going across this side, I'm going to have 3 tenths, right? Because that's my other factor. So I'm going to change to a different color highlighter. And now when I draw my 3 tenths going across, though, I'm going to go all the way across this entire thing and shade in all of this, right? So that is 3 tenths shaded in, perpendicular to how I shaded in the 1 4 tenths. So now what we need to do is we need to look at these two pieces together and think, what do we have? Well, here I have 3 by 10, right? So in this first model, I have 30 units that are shaded in both colors, right? Remember, I forget to, I guess, highlight that fact that all I care about is where they overlap. Now over here, though, on this one, I have a 3 by 4, and 3 times 4 is 12. So for this first model, I had 30 hundredths. For the second model, I had 12 hundredths. So I'm going to put those two numbers together. Well, 2 plus nothing is 2, and 3 plus 1 is 4. And here I get an answer of 42 hundredths, right? Because I needed to put together all of these units and all of these units. And 30 plus 12 is 42, and they are worth hundredths. So keeping that idea in mind, right, we had our two factors were 1 4 tenths and 3 tenths, and our answer was 42 hundredths. Now, if we look at these, right, 1 4 tenths, this factor is bigger than my product. but my second factor is smaller than my product. So both of these had a decimal in them, right? But for some reason down here, I got an answer that was bigger than my factor. Remember, that wasn't happening earlier on in our math that we were doing, these first couple of problems, right? We ended up with numbers that were smaller, right? 56 hundredths was smaller than both of these factors. So let's talk about why this product is bigger than this factor. And it has to do with this. It has to do with the fact that my other factor is greater than the number 1, right? Because when I multiplied this first part of my model, when I multiplied these 3/10 times 1, I got 30 units, right? I got that number right there, and that is 3/10, right? Remember, this factor is already 3/10. So 3/10 times 1 gives me an answer that is equal to 3/10. Well, I had this whole second piece of the model here that I had to multiply it by as well, and that gave me this extra little bit, right? So anytime we multiply a number by another number that's greater than 1, we're going to get something that is bigger. And that is why we end up with a product that's bigger than our factor of 3/10, right? And the same reason kind of applies to this part, right? 42 hundredths is less than 1 4/10 because 3/10 is less than 1. Really, that number is the most important. All right, we're going to try 2 more really quick. Why don't you pause the video, come back, and take a look at the answer and see how you did. And I'm going to try to go through these quick. So go ahead and pause it and come back. All right, we're going to start with this one. We're going to do 9/10 times 6/10. Grab a highlighter. All right, so we're going to start off with 9/10. So that is all but one of these that is shaded in. So hopefully we're starting off with 9/10. We're going to switch over. Now we're going to get all but 4, right? Because that's where we would get 6/10. We're going to come back and identify where do they overlap. And they overlap right here. And this gives me a 6 by 9 array. 6 times 9 is 54 units. I know that each of those units has a value of 100th. So the answer is 54 hundredths. All right, our next one. Remember, we're going to do the smaller number going across. We're going to do our larger number using both of our models. So let's go ahead and start here. We're going to shade in one full model, right, going up and down. And then after we get this one all shaded in, we're going to shade in 2/10 of our other model. Okay, switch our color. Now our 5/10 goes all the way across both of these so that we get everything we need shaded in, right? So there's 5/10 of this first one, and we shaded in 5/10 of the second one. Switch back to our pen. This is the part we care about. Here in this first one, we get a 5 by 10, which gives me 50 units. In my second bit, I get a 5 by 2, which gives me 10 units. 50 plus 10 is 60. And again, each of these individual units has a value of 100th. So this is 60 hundredths, which we could also just write as 6/10. All right, so give the problems in this lesson a try. And as always, let me know if you have any questions.